Today we'll be doing a detailed discussion on the zeros of quadratic polynomial in one variable and roots of quadratic equation. Okay, before going deep into that relation, first we need to understand what is the meaning of zeros of quadratic polynomial in one variable. Okay, so for that we need to know polynomial and zeros of just polynomial in one variable. Okay, and also we need to know roots of quadratic equation. So let's start. I'm Khush-Want Singh, MSc Mathematics, B.Ed are my qualifications. So over here we have got first slide, zeros of polynomial in one variable. Okay, what is a polynomial? The first question. The form a1 x to the power 1 plus a2 x to the power 2 plus a3 x cube plus a4 x to the power 4 plus so on. This type of thing is called polynomial in one variable. Okay, here a1, a2, a3 and so on, these are real number. Okay, and x to the power 1, x to the power 2, x cube, power 4 and so on, these are actually variables. Okay, and only one variable we have used over here, and that is x. Okay, here also x, though polynomial, if you go into the meaning, then variables can be more. Okay, now we need to know the zeros of this polynomial. Okay, so what are zeros? Zeros are actually the points where the graph cuts x-axis. Okay, so there are two methods to find zero. One is we assume the polynomial to be 0 equal to 0, and then we solve for x if the polynomial is in variable x. Or second method is we plot the graph of that polynomial, and all the points where the graph cuts x-axis, those are actually the zeros. Okay, and these things we are not going into detail because then it will be quite lengthy. Okay, and if you need to get more information on this, then I can make another video on this. Next, we'll start from linear polynomial. Linear polynomial means degree 1 polynomials. Okay, example 2x plus 3. So first is algebraic method. Okay, so in algebraic method we have learned that the first thing which we do is let this polynomial fx to be equal to 0. Okay, so let fx equal to 0, so 2x plus 3 is equal to 0, and when you solve it you'll get 2x equal to minus 3, so x is equal to minus 3 by 2, hence x is equal to minus 1.5. Okay, let's see whether this is only the 0 by graphical method or not. Okay, the polynomial is 2x plus 3. Now we have got a graph over here. I'm just writing 2x plus 3. Okay, now as you can see the graph is cutting x-axis at the point minus 1.5 comma 0. Okay, so this x coordinate is called 0, so 0 is minus 1.5. Okay, so over here we have also got minus 1.5 by this algebraic method, so hence it is correct. Okay, both the methods are working. So for this case the first thing we'll do is let 5x minus 2 is equal to 0, so I'm directly writing the answer x equal to 2 by 5, which is equal to 0.4. Okay, let us see by graphical method. 5x minus 2, 5x minus 2, so we are getting this purple line. Okay, so x coordinate is 0.4 and over here we had got 0.4, hence both are working properly. Okay, both are giving correct answer. Now, before going further, I need to just discuss on it a little more. I only wrote over here 5x minus 2. I didn't wrote fx equal to, okay, but it is assuming it to be fx, okay. And let's see what happens if I write y equal to 5x minus 2. Okay, now over here this black one, we are getting the same line, okay. This y equal to 5x minus 2 and 5x minus 2 both are actually same line. This violet line, let me remove this orange line, violet line and black line both are same, okay. Same goes with this 2x plus 3. If we write here y is equal to 2x plus 3, still it will be same line, okay. Here y equal to 2x plus 3, orange line, still orange line even after removing y, okay. So if we are not writing anything, if we are just writing 5x minus 2, it means it is taking itself that to be equal to y, right? It is on itself taking this to be equal to y, okay. And why have I said this? Because these will be required later on, okay. And just one last thing which I want to show you, if we write 5x minus 2 is equal to 0, we will be getting a straight line, okay. This red one, this is a straight line parallel to y-axis, okay. So do not forget this, look at it closely. And this point, the at the place where this graph cuts the x-axis, that point is 0.4, same point where the earlier graph was cutting, okay. All when you write y equal to 5x minus 2, this line also crosses x-axis at 0.4, okay. And when you write 5x minus 2 equal to 0, here also it is crossing x-axis at 0.4, okay. 0.4 means 0.4 x coordinate, okay. Now so linear polynomial is clear. Next, quadratic polynomial. Quadratic means degree 2. So all the polynomials whose degree is 2 will be categorized as quadratic polynomial. Example, x square minus 2x minus 8 minus 4x square plus 4x minus 1 and this one, okay. In all these three examples, degree is 2 or highest power is 2, okay. We are not solving it right now because we'll be solving it later on along with quadratic equation, okay. Third one, cubic polynomial. So cubic polynomial means degree should be 3 in that polynomial, okay. So examples, x cube minus 4x or x cube minus 2x square or only x cube, okay. So let's see, just try to solve. So as we saw, the first thing is let fx equal to 0, okay. So x cube minus 4x is equal to 0. We can take x common over here, so x and x square minus 4 is equal to 0. It can be factorized further like x square minus 4, that means x square minus 2 square, okay. And it can be written as x, this is in the form a square minus b square, okay, which is a minus b into a plus b. So a minus b, a plus b equal to 0. Now we have got three bracket x, x minus 2 and x plus 2. All these three can be equal to 0, okay. So when x, the first bracket, is equal to 0, then value of x will be 0 only, okay. When x minus 2 is equal to 0, then x is equal to 2. And when x plus 2 is equal to 0, then x is equal to minus 2, okay. So the three zeros will be x equal to minus 2, x equal to 2 and x equal to 0, okay. 0, 2 and minus 2 must be the zeros or must be the points where the this graph crosses or cuts x axis. So let us see by graphical method whether it is the same. X cube minus 4x. Let us try x, and for this cube I have to do some trick. X cube, and after that, one second, minus 4x. There is some error in this. Okay, x cube minus 4x we've got. So this graph is crossing x-axis at 3 points. This one minus 2 0, this one 0 0 and 2 0, and x coordinate of these 3 points are minus 2 0 and 2, and I guess we got the same 0 2 and minus 2, and here also same 0 2 and minus 2. Okay, that means it is holding. Okay, our method is working. Okay, similarly if you solve this one, then you can take x square common, then you'll get x minus 2 in bracket, and it means x in one bracket, again x in one bracket, in third bracket x minus 2. Okay, so the zeros will be x equal to 0, x equal to 0, and x equal to 2 when you equate these three to zeros one by one. Okay, but we will be writing only this because we have got x equal to 0, x equal to 0 two times. Okay, so we'll be writing just one time. Okay, zeros are only two in this one. Okay, in this one zeros were three zeros were there, 0 2 and minus 2. Okay, because all three values were different, 0 2 and minus 2 are different numbers, but here 0 0 and 2, these two numbers are same, so only one of these will be taken. Okay, hence we'll be having two zeros, 0 and 2. Let us see the graph. X cube minus 2x square. So x cube minus 2x square. Okay, let me move that. Now if you can see the graph, it is actually touching or crossing x-axis at 2 points only, 0 0 and 2 0, only these 2 points. Okay, but the interesting thing is this is actually not crossing x-axis over here. If you can see 0 0, this point, this graph is not crossing x-axis, it is just touching and then bending. Okay, so this thing will be used further. Okay, so do not forget it. Okay, we had got two equal zeros to be 0 and 0. Okay, this 0 came twice, and this 0 came twice, and over here if we see in the graph, it is just touching this. Okay, so there is some relation between them. If there are two common zeros, same zeros, then the graph will touch it. Okay, touch and then bend in the same direction. Okay, like it was from here, it is going down in this side also going down, it is just touching it, but here it is actually crossing x-axis. Okay, so do not forget it. The last one, x cube. So x cube, again you can write x into x into x is equal to 0. Hence, you will be getting x equal to 0, comma, x equal to 0, and again x equal to 0. Okay, and as we discussed that common numbers are not taken, so we'll be having just one 0, and that is 0 itself. Okay, let's see the graph. Because common number we don't take zeros. Okay, let's see the graph. X cube, so x and over here 3. Okay, so if you can see closely, it is just touching it for a very long time. Okay, it is just being with 0 0, like if you come from this side, then you can see that it is not going completely up at all at once. Okay, so zeros are means actually there is only one zero. Okay, so common zero is just one zero over here, just one zero is there, and that is zero. Okay, next, now we'll be discussing quadratic equation. Okay, we know that quadratic equation in variable x, it means degree should be 2. Okay, quadratic means degree should be 2, and equation means equal to sign should be there. Like x cannot be there, x square must be there because degree should be 2, and equal to sign should also be there. So x square equal to, let's say, 2. This is an example of quadratic equation. Okay, and because degree is 2, you can also write x square plus 2x plus 3 is equal to 0. This can also be quadratic equation because it is satisfying both the properties. One is degree should be 2, and degree over here it is 2 due to this. Okay, and second one, equal to sign should be there. Here equal to sign, and over here degree is 2. Okay, so these two are examples of quadratic equation. Okay, once again, yes, these two are examples of quadratic equation. We can write more examples. 2x square minus 3x plus 5 equal to 0, and likewise infinite examples. Okay, so let us move forward. So over here we have got some examples also. You can see all correct. Okay, now the quadratic equation in variable x degree 2 form is ax square plus bx plus c equal to 0. Like we saw over here in these two examples, or in these examples, the form is what? Over here some number is there before x square. Okay, before x square some number is there, like over here 1 is there, over here minus 4 is there, over here 2. So a x square plus bx with x, there can be, sorry, there will be some number, whether 0 or minus 2, 4 or root 2, anything. Okay, plus c is equal to 0, and here also plus some number, like here minus 8, here minus 1, here plus 5. Okay, and a, b and c all are real number. Okay, all belongs to real number. The form is ax square plus bx plus c equal to 0. Okay, so form we have seen. Now there is a quadratic formula. Okay, so the formula is x, like for this question or this example or this form, x is equal to minus b plus minus root under b square minus 4ac whole divided by 2a. Okay, so there will be two roots. Okay, one root will be x equal to minus b plus root and b square minus 4ac by 2a, and second one will be minus b minus root under b square minus 4ac divided by 2a. So in short we just write plus minus all at once, because only difference is this, over here it is plus and over here it is minus sign. Okay, and this thing which is inside this root, this is called discriminant or capital D. Okay, so D is equal to minus b square minus 4ac. Okay, this thing. Okay, so clear. This is the formula for x. Okay, we have to find the variable x over here. So x is equal to whole of this, means minus b plus minus root b square minus 4ac by 2a. Okay, and this root under one is called discriminant or capital D. Okay, now the interesting thing is quadratic equation will definitely have two roots always. Okay, always it will have two roots. Okay, and we'll be seeing them very soon. But when we see polynomials, like in this case we were getting three zeros, 0, 2, minus 2. Here we got two zeros, 0 and 2. Here we got just one zero. Okay, here only one zero was there, here two zero, here three zero. So zeros are different thing. Okay, zeros are the places where the graph cuts the or touches the x-axis. Those are called zeros. Okay, and the maximum number of zeros can be the power or the degree. Okay, maximum number of zeros will be the degree. Like over here, the degree of this polynomial is 3. Maximum number of zeros will be 3, and we got 3 zeros. Here also degree is 3. Maximum number is of zeros is 3. Okay, but it can be less than 3. Like here we got just two zeros, which is 0 and 2. Okay, here also maximum number of zeros will be 3, but we got just one. Okay, maximum is determined by the degree or the power, highest power. Okay, likewise in linear polynomial we were getting just one zero. Okay, and the degree in this linear polynomial is 1, and we got just one zero. Okay, maximum we got one zero, so we got just one zero. Okay, so